As a former managing director of BP, I don't need persuading that oil is a wonderful fuel. But it's going to run out. There are 7 billion people in the world now, and we need to find an alternative energy source, and quickly. Hydrogen offers the best possible prospects, and here in Celle we have a real example of how it can be used. It's the very best of British science. It's a spin-off from Oxford and University College London. It's led by a very eminent scientist, Stephen Bennington, with a great team underneath him. And it's managed by a chief executive, Stephen Voller, who's got a proven track record in developing venture capital companies. It's got the backing of Space Florida in the United States, and we've opened a laboratory there, and there are a number of possible space applications for this.
Celle Energy makes safe, low-cost hydrogen storage materials. The world demand for energy is expected to triple by 2050, and hydrogen will play an increasingly important part in the energy mix going forward. But when most people think of hydrogen, they think of hydrogen gas that comes in compressed cylinders. Clearly, it's going to be very difficult to package that for vehicle applications. Also, when people fill their vehicles, they're used to using a virtually foolproof liquid pump, and they stand there for maybe 3 minutes, and then they put enough energy in their vehicle to drive 300 miles or 500 kilometers. So any new fuel has got to fit in with the existing infrastructure and the existing way of doing things.
Well, this is the Celle Energy Laboratory here at the Rutherford Appleton site, and here we're trying to make cheap, low-cost hydrogen storage materials. We've been working on these materials since about 2007 in collaboration with both University College London and Oxford University. Now, plenty of materials store hydrogen in a solid form, but they suffer from a series of problems. One of which is that a lot of them are air sensitive. In fact, some of them are so air sensitive that they'll burst into flames on contact with air. It's clearly not good. And also, some of them, if you heat them up, perhaps to about 85 or 100 degrees centigrade, they can take many, many hours for the hydrogen to come out. So what we've done is to, first of all, try and make the materials safe, and also try and make them in such a form where the hydrogen can come out more easily. And to do that, we've used a nanotechnology, a cheap, scalable nanotechnology. So we use a process called electrospinning to make these very, very fine fibers, which are about 30 times finer than a human hair. In this form, each fiber is coated in plastic that stops oxygen getting in, so it can no longer catch fire, it's no longer pyrophoric, but it allows the hydrogen out. And secondly, in this nano form, the hydrogen can come out incredibly quickly. So what we then do is we squeeze that up into a tight little pellet like this. And in this pelletized form, the hydrogen still comes out extremely quickly, but they're much easier to handle. In fact, if you make them into little M&M type shapes, you can imagine that it's like a fluid. And that kind of fluid we can pump around. We can pump them into your car and then back out of your car. And each one of those little pellets will drive your car a few seconds, so you do need quite a few.
The early development work is done, and Celle is now ready to move from proof of concept through to field trials. We have large opportunities in the transport sector, but it will take time to implement. So we're working with industry partners in sectors that are nearer to market. These include laptop batteries, extending the life of laptops and looking at cloud computing. They include batteries for military applications. Our materials are also effective radiation shields, protecting both astronauts and satellites. Working with NASA, we'll be launching twice in the next 12 months, once to the International Space Station and another into a polar orbit. Our technology lends itself to low-cost, large-scale manufacturing. We can meet all of these market needs, and we have a very exciting future.
We've all driven miles out of our way to save a penny a litre or a penny a gallon on fuel. So what we also know is our technology has to be competitive for people to adopt it. So where we focus is in producing safe, low-cost materials that can be used just like a liquid fuel today. The most important thing is that we don't need a huge investment in infrastructure to implement this. And that means we have to work with the oil industry to make this happen.
So here we have a potential alternative fuel, hydrogen, which could replace oil in the long term. And in the meantime, while we're waiting for this very high reward, there are alternative uses in batteries and in space which will help us fund the development program. I recommend it to you very strongly.